Okay, let me begin. Welcome to the Sec 4 A Math Additional Mathematics WA1 Online Revision. Okay, this is a revision for linear law. Okay, linear law. Three. There should be another one. I think it's three go. I think that's a different date. Okay, so this is for linear law. Just to let you guys know. Okay, anybody who is not in Sec 4 A Math or basically if you are doing linear law, this is for you. Okay, I think sec 3 some of y'all learn linear law, but I don't think this early also. Okay, so anyone that is not learning this topic, you can leave. Okay, just let you know first. Okay, so yeah, for the rest, welcome. Okay, welcome to Overmark WA1 Online Revision. So I am going to introduce myself first. Okay, and I think you can see from pictures, there seems like people are having fun, that kind of stuff. There are some events, go movies, kind of thing. Yeah. So that is, I think, the one thing that makes us a little bit stand out lah. Okay. So just a quick introduction to myself. Okay, I am Qian Wei. You can call me Zhe. I think that's the easiest way lah. Everybody call people Zhe lah. I also do that also. Okay. My surname is Ong, Mr. Ong. Okay, Mr. Qian Wei, Mr. Zhe, anything. I'm really fine with anything. Okay. So a little bit of background. Okay. For Overmark, I just joined not too long ago. Okay, and I'm a fresh graduate from Nanyang Technological University. Okay, for those aspiring to go NTU, hope to see you guys. Okay, so what I teach in Overmark, right? Okay, is lower secondary math. Okay, which I have a class that is pretty big, like almost 15 students. Okay. And additionally, I also teach E-Math and A-Math. Okay. Primarily A-Math, I have a lot of A-Math classes. Okay, so I focus on Sec 4 A-Math. I also have a Sec 3 A-Math class. Okay, currently I'm teaching certs. Okay. And for lower sec, I teach Sec 1 and Sec 2 lah. Both I will teach lah. Okay. So mainly what did I do? Why am I a tutor over here? Okay. First thing first, I do mathematics in university. Okay. So I've taken a bit more background. I've taken A-Math, of course. Definitely, if not, I won't be teaching A-Math, right? Then I also have done JC, H2 Math. I also took H3 Math. Okay, if anybody interested, I took H3 Mathematics. Okay, which is a higher level. Basically, in JC is a course that links that is basically university kind of module lah, which I actually took. Okay, fun fact, I failed that subject. Okay, something that to me is fine because end of the day is just something I want to take for fun. Okay, and of course because the module itself is a university module, right? So when I took mathematics in university, I took a few courses related to my H3 subject, and I did very well in those subjects lah. So definitely at that point of time, failure to me is just another point of time that okay, I get to learn from my mistakes. I learn from back then, and I become better, right? So I think that is the mentality that I built in myself. Okay. Again, I will send the link to those who. I'm not sure if the people who just joined got the link or not lah. I will send it again. It's just to be sure. Okay. So a bit of fun fact. I taught different mathematics. I taught university math also. I taught mainly normal acad students. Yeah. And I also taught one A math student along the way. Yeah. And my mission back then was to help students who were not doing well to pass. That was the kind of things I started with. But right now I have students under me, right, that are actually doing better. Okay. I mean, this is not I'm not promoting myself, it's just something I'm sharing. And I feel that, being over here when I have students that improve, I feel very proud. And I feel like it's a sense of achievement that your students are doing better, right? I mean, if you're a parent, you want your kids to do better, right? So that is my take. And fun fact, I hate dried cuttlefish lah. And so if anyone were to be my students next time, please don't give this to me. I hate it. I really hate it. Okay? Now, to share more about Overmark, right? For those who are new, those who already know, good for you. Okay, for those who are new over here, okay, Overmark itself, we have many branches. I think currently 6 or 7. We are expanding, right? So, for me, I teach Tampines, Marine Parade, Kovan, and Bukit Timah. Okay, I stay in the East lah. So of course, I guess I'll have more classes in the East lah. I mean, I guess, right? And to top it all up, okay, in terms of results, right, 70% of overmarked students achieve distinctions at their national exam. Basically, I think A1, A2 lah. Okay, and of course, our background, most of us are from NUS, NTU. Not that. I mean, I am also from NTU lah. Okay, and I think a lot of us are from TLL and MOE. Okay, I am not. I am a fresh grad, as I mentioned. Mm. Okay, so in terms of resources, right, we have plenty of resources, right? And for those who join, right, you will get curated notes. Basically, for the subject that you are doing, you will get the notes for that particular subject. Mm. And of course, for most tutors, I believe, if not all, we will do. Okay, I think weighted assessment revision we definitely have, which is this is one of the packages, right? Then I think one thing that we also have is mock exams lah. So like mock prelims, EOY kind of things, right? For the sciences, we do offer practical sessions, and this is something that I think is even for me, I think is very unique. That because back those days, I have never heard of tuition centers that have practicals, right? And this is the first one that I actually heard of. I'm not sure if you guys have heard of any others. Maybe I boomer lah. Okay, and we also have other type of notes and that kind of stuff. For me, my classes I do write my own resources and share to my students. Okay, and I think depending on the tutors themselves, we also offer after class consultations. Okay, but of course, for me, okay, if you're in my class, subjected to my timetable, of course, you can't expect me to reply at 1 a.m. that kind of things lah. Oh. Okay. Of course, at the end of the day, if you guys like the lesson, I hope you do lah. I want to make this as fruitful as possible. Okay, please do scan this QR code. In fact, you can take a picture now. And then scan it, then just leave a review lah. Okay. Okay, so this one I will just run through. This one is just the list of classes that you have. You basically can find this information on the website. Okay, so not to worry. More so for me, if you will see my name over here, I'm taking a Sec 3 AMAth class in Kovan. I also take AMAth classes, Sec 4 AMAth classes in Kovan. And basically Kovan I got one Sec 3 and Sec 4 AMAth lah. And then for Marine Parade I got an AMAth Sec 4 class. Right? So that is for me. Okay. Basically, I will just leave this for a minute lah. Anybody want to scan can go and scan first. Okay. So I just want to check. Everybody got a copy to the notes, right? That I sent in the group, the drive. Okay. If don't have, please let me know. Okay. I just leave this for a minute. See if anybody needs to scan this. Okay. If not, it's in the website. Don't need to worry too much. Okay, by the way, I just let you guys know I'm currently a bit unwell. So if my voice sound a bit weird, please forgive me. Okay? I will do my best to project as much as I can. Oh, okay. Yeah, I think can let me move on to the content. Okay. Oops. It's over here. All right. Okay, welcome officially to linear law. Okay, so linear law itself is a very small topic. To be very frank, I think small is one of the smallest topic in AMF lah. Okay, and for those who already started on differentiation, that topic will be okay. Ken, let me send it to you again. Thanks. Okay, something no choice . All right. Please let me know if you got received lah. Okay, I will move on first . Okay. I will do a quick introductory. So this is one of the topics that is very small. Okay, if you all started differentiation, I believe that topic is very huge lah. Okay, especially for G3 students taking express. This differentiation and integration is one whole package. Okay, it's very big. Okay, compared to linear law, I think 2 weeks, 3 weeks finish very fast. Okay, but what are the main components of linear law? Okay, I'm going to simplify for you guys because linear law itself, the question that come out of it is very standard. Okay, so linear law itself got 2 primary components, maybe 3 lah. Okay, but I think the last one is so small to me it doesn't really matter. Okay, so the first component okay, what happened to my pen? Okay, never mind. The first component itself, okay, is to convert non-linear equations into linear equations. Okay, I believe most of you guys remember, right? Okay, I hope you guys remember lah. Okay, second one is to revise how to convert linear form back into non-linear equation. Okay, so you need to know how to convert from non-linear to linear, but you also must know how to convert from linear to non-linear. Okay, and sometimes they will even ask you make y the subject, right? And some of these will involve some of your very usual techniques like cross multiplication, factorization, kind of things. Okay, usually your standard techniques are involved. Okay, and just take note, I will even extend this out to our other topics. Okay, even things like proving trigo. Okay, you will tend to use a lot of these techniques. Okay, factorization, expansion, and then your identities, these kind of things. Okay, so a lot of techniques are very standard. You just need to know how to link them from one step to another step, right? And last but not least, you need to know how to plot, okay, the points onto a graph paper, and then actually evaluate it, right? So that is the most important component lah for me, okay, in this revision. So let's start off with with this. Okay, what's my sorry, my pen today got a bit of issues. Okay. First thing first, linear equations. Okay. Most of you will remember linear equations as y equals to mx plus c. Okay, which is over here. This is the very standard form. And you all should know that m represents your gradient, c represents your y-intercept. Okay. And so that is for a standard linear equation. But what if your equation is non-linear? So I'm going to show you guys a few examples of non-linear equations, or rather linearized equations, right? Okay, so for this one, you will see that you have three equations over here, right? Ln y equals to 5x plus 2. Okay, then you also have y over 3 equals to 2x minus 3. Now, basically, you will notice that all these things, right, okay, they have something in common. Okay, and then the last one, root y equals to minus 2x plus 1. Okay, my pen is currently not working. I will maybe adjourn for a 5-minute break just to fix this problem first. But I can quickly just run you through these three equations. I hope you all can see there are three terms. Okay, ln y, right? Ln y, okay, equals to 5x. Now, the ln y itself, right, is a variable group. I call it a group, right? You see it as a block. But this block, right, has a coefficient of 1, right? And then you move on to 5x. Okay, you see another block, which is your x, right? And then you see a coefficient of 5. And that coefficient is not 1, right? Okay, and then you have plus 2. This term is independent of any variables, which makes this a constant term. Okay, so can you see that this is really just your y equals to mx plus c, right? Oh, right, finally working. Okay, not working again. And never mind. Okay, then you all see the next part, right? Okay, y over x is equal to 2x minus 3, right? Okay, so for the first part, you will notice this part is independent of any constant terms. Any coefficient other than 1. As in, yeah, so this coefficient is 1, right? And then you move on to equals to 2x. Again, the block is x, right? And then you have a coefficient of 2, which is not 1, right? And then you have a constant term, minus 3. Okay. Last but not least, again, I'll quickly run through. Root y itself is one block. There is no other variable you see. It's just the coefficient is just 1, right? Equals to minus 2x. Okay, the x itself, right, is one block again. And then you have minus 2, and then you got plus 1. So this makes this thing linearized because because you can form big groups of y and big groups of x. And your x terms, all of them, right, if you notice the 5, the 2, and the minus 2, right, each of them, they have a coefficient that's not 1. Okay, sometimes, I mean, it's possible to have 1 lah, right? Okay, but in this case, the coefficients are not 1. So these are what we label as your x, your big x, right? And then you have your constant term, which is your 2, your minus 3, and your plus 1. Okay, I hope you all can see this. All right. Okay, so this part very wordy. Okay, but it's basically what I explained to you earlier on lah. Okay. Um, and that being said, I hope you guys actually recognize that there is more than one way to linearize a graph. Okay. So for example, you can in one line you can actually multiply by x, another line you can divide by x, and you will still get linear forms, right? So let's take a look. Okay, I hope my pen is working. I don't know why it's not working. Okay, I think y'all give me a short while. Let me try to fix this. The pen should be full. Oh my god, it's finally working. Okay, sorry for the inconvenience. All right, so let's take a look at how we can do the transformation for each of these following examples. I'll make it quick lah. Okay, so for this one, I hope you guys observe that there are three groups. Okay, this is your big Y because it's a variable independent of X. But then you realize there's an issue, right? These three terms also contain variables, right? Okay, so how I like to tell my students is I want to make sure that one of these variables, right? Okay, one of this group is a constant. And in total, y equals to mx plus c, right? So I have one, two, three terms, of which one of the term must be a constant. So if you look over here, none of these terms are constant. So what can I do? Okay, I can do two things. Number one, I can times x. Sorry, I can divide by x. Okay, why? Let's look at this term. If I want to make this term a constant, right, my variable is x. If I divide this whole equation by x, right, then I will be down to y over x equals to a plus bx. Hmm? Okay, and then in this case, right, this is your y, this is your mx, this is your c. So, of course, some of you like to rearrange, right? Okay, so we will just rearrange. Okay, plus a. Okay, so this is your c, y equals to mx plus c, right? So you can quickly identify that this is your y equals to mx plus c. Another way to do it is I want to make this group the constant group. Okay, so let's say we have this. So what I can do over here, okay, is as follows. Instead of dividing by x, I can divide by x squared. So I will have y over x squared equals to a over x. Now, because x over x squared, right, is equals to 1 over x, right? That's why we have this. So this is plus b. Now you notice that this is your big Y, this is your mx, this is your c. Your a over x can be split into a times 1 over x, right? So that's how you see your constant term and your variable term, your variable group. Okay, I like to call it a group lah, per se. All right. Okay, next. This one, straightforward. This is already in your y equals to mx plus c. You only need to split up the a and the over x. Okay. Another way that people like to do it, which I will advise not to, because we overcomplicate the matters, is you multiply the whole thing by x. But come on, guys, why would you want to do that, right? Okay. If you are, I mean, there are people who do it. I tell you first, there are people who will do it. Okay, but logically speaking, this is good enough. So try to observe first before you make any moves. Okay, be a bit more observant. Don't just rush through everything. Sorry, move up a bit, meaning. Oh, you want to see, huh? Okay. If I zoom out, you can see or not? Because I'm moving down already. Okay, maybe like that. Is that okay for you? Okay, can. Okay, so last but not least, this is similar to this. Similar, right? Okay, the only difference is you have square root of x instead of x, right? And then this term is in the denominator, right? So what you can do is, again, let's take a look. We have three terms. Okay, so for each of the terms, okay, I want to make sure that one of the group is a constant. And so you have a few options. This one you can divide by root x, or you choose this to be a constant term, you can multiply by root x. So you can see in this diagram over here, I have given you an alternative, okay, and I also given you the main method. So you can take a look at your notes, okay. I'm not going to delve this one in too much in detail, okay. I move on, okay. Now, this one, again, you have three blocks, right? X, Y, A over X. Yes, correct. We have to manipulate into Y equal to MX plus C. Okay, the only thing is as I said, there are more than one ways to do it. As long as you can get it into Y equal to MX plus C, that's good enough already. Okay, unless the question asks you, okay, I need to, how do you say, if I need to find my M and find my C, right? Then you just make sure you state it clearly. Or if they tell you what is your Y, what is your X, then you just state those clearly. Okay? So for this one, xy equals to a over x minus bx, right? You notice that all three of them got variables again. So now, you just need to choose. Do you want this to be your constant term? Do you want this to be a constant term? Okay, so it's really up to you. For me, if I make this the constant term, right, I need to see what is my variable. Okay, it's 1 over x, right? So in order to get rid of x, 1 over x, I need to multiply the whole equation by the reciprocal, which is x. So I will multiply by x. And then I will get x squared y equals to a minus bx squared. Can? Okay. Next, okay, again, this one got alternative. But I will much prefer to multiply than to divide. Okay, this one is for those who have done exponential and logarithms. Because you see that your x is in a power, or you have x raised to a power that is a constant. Okay, so this is just one scenario. There are a few other scenarios like x power a. Obviously, your a, you don't know what power is that, so you cannot be using this as it's not like x squared where you can't really use this as you can use x squared as a variable, right? But you can't really use x power a as your big X, right? It's not really possible. You have to bring down the a, okay? Because a is unknown. That is the difference. And when a is unknown, right, it makes your computation difficult. When you do your actual plotting of y against x power a, then you must be thinking, I sub in the value of x, right? Then I don't know what's my a. Then how do I find my x? So it doesn't make sense, right? So we have to bring down the a. Okay, so in these cases, right, where you have powers that you need to bring down, right, you apply logarithm. Okay, so just a quick revision, okay, your logarithm rules, right? Okay, ln AB is equal to ln A plus ln B, right? Ln A over B is ln A minus ln B. And last but not least, you also have the power rule. Okay, this is equal to n ln A. Okay, this is the main one that we are going to use. Okay, we are going to apply primarily this to this technique. So whenever we see non-linear equation, we just manipulate it to okay. I think to add on to okay, so somebody asked, whenever we see non-linear equation, we just manipulate into one y equal to mx plus c. Okay. This one has got to do with spotting questions to identify what are you answering. Okay, because your whole A math, there is only one question that will ask you to write linear form. This is the only one. Okay, so there's no other topic that will ask you to write into this kind of form. I hope I answered your question. Okay, so back to this. To break this up, we are going to apply our product rule first, because you see, these two are in products. Okay, if you see your A as one group and you see your BX as the other group, you can apply your ln y equals to ln A ln BX. Okay, then split them apart. Ln A plus ln B power x, right? The next thing to do is this x, because it's in the power and it's inside the logarithm, you can use your power rule. So this will be ln A plus x ln B. Okay? So you get this. And quickly you will identify that this is the y variable because it is one group, it has no coefficient. The coefficient is just one. Okay? And then you have ln A, this is your constant term. And then you have the last term, which is a constant and a variable group. So your variable group is x, your constant is your ln B. Okay? Alternatively, you can use log LG, okay, log base 10. Okay. Other than these two, please don't try anything else funny, like log base 2, log base 3. Don't need. Your calculator cannot handle all these value, right? Or rather, it's not convenient to handle all these. I don't remember whether your logarithm, your calculator got this. I don't remember it's have one. Okay. So just I thought ln is only when there is E. Yeah, correct. But you don't need to choose a base to split them apart, correct or not? You get what I mean? So you don't have to choose in particular ln or log based on this scenario. You know what I mean? Okay. So you can just use log, you can just use ln. Okay, and because at the end of the day, you use ln, you use log, right? You still get this part, right? I think the very special case is if you have uh so this one you can choose, but if there is E, you can only use log. Okay, I give you a quick scenario of how what happens if you have E inside. So let's say you have y equals to E bx, right? If you apply ln, right, you get this, right? Ln E plus ln bx, right? This part becomes what? 1. This part becomes x ln b. So technically, this is a constant, but the constant is fixed. That's all. I don't think a question will actually test you on this, to my knowledge. So I don't think you should be expecting these kind of things. It's quite out of the ordinary if you ask me. Okay, but this is what happens if E is involved. It doesn't mean you cannot use. It just means that this is what happens. Okay, can. Let's move forward. Okay, so I'm going to run you through the standard techniques to apply your your linearization. So only 4 things to remember. Okay, cross multiply is when you see fractions. Like for example, y equals to 1 over x squared plus 1. This kind of things when you see your denominator got many terms you want to try to bring this up to the same line as everything else. So you use cross multiplication. Some people even more convenient. You just do a swap. Okay, you just do a swap between these two terms. So you get 1 over y equals to x squared plus 1. Also okay. In fact, this is the one that is most likely to happen. Okay, now addition subtraction basically means move left and move right to the right side of the equation, left side of the equation. Multiplication and division is basically whatever we did just now. Okay, then to differentiate between everything else is this technique, logarithm techniques. It is when your constant terms and your variable terms are in product form and you need to break them apart. Then you use logarithms. Okay, so actually very classic. When you see y equals to a whole chunk of thing in product form, then you use this technique. Okay, otherwise it's don't need one. If you already have 3 terms, you usually don't need to break them up apart anymore. Okay, so your steps is apply your algebraic manipulation to shift things around, and then you identify your variable y, your y group, and your x group. Okay, depending on which one got a coefficient that is not 1, that kind of stuff Okay, and then from there you see what's your m, what's your c. Okay, so let's move on Okay, I will quickly run you through. Yes, wait. So you use log only when they are all multiplied together and when there is a power. Yes, usually that's the case. I say usually okay, because again it depends on question, but most of the time yes. Okay, so for this question, right, I will quickly show you guys how I actually can do this very quickly. Okay, so for part A, okay, 1 over y equals to ax plus x over b. First thing you check, 3 terms. Do they have 3 terms? Okay, if they have, then good. Let's move on to the next step. Which of these 3 terms, right? Okay, so you have 1, 2, 3. Which of these 3 terms have a constant term? Don't have, right? All got variables, right? So you will need to choose one of them to get rid of the variable so that you can get a constant term, So let's say I choose this one, a over x, right? Okay, what do I need to get rid of? 1 over x. So to get rid of 1 over x, I do the reverse. I multiply by x. So if I have 1 over x equals to a over x plus x over b, right? If I multiply by x like that, then in my next line, I will get x over y equals to a plus x squared plus b. And so you will quickly notice that this is your y, this is your mx, and this is your b. This is your c, sorry. Okay, and in this case, your values of m is the value that is together with your x, your big X. Okay, in this case, your gradient is your 1 over b, and then the standalone coefficient or the standalone constant term is a, that will be your c. Okay? Okay, next, for part B, okay, y equals to x squared plus ax plus 2b. Now, this one very tricky. This one got 4 terms, right? Okay, what can we do to make sure that we have 3 terms? Okay, a quick observation tells me that, you see, you have a y term over here, you have an x squared term over here, right? Both of these, what do they have in common? Okay, their coefficient, if you notice, is 1, which means if you can group them, somehow you can group them together, they can become your big Y. Make sense? Because their coefficient is 1, right? So I can group them together. So what I can do is I can actually move this into this side. And so I will get y minus x squared equals to ax plus 2b. And what will happen? This becomes your big Y, this becomes your mx, and this becomes your c. Okay? And therefore, m is equals to a, c is equals to 2b. Can? Okay. At this point of time, anybody don't understand anything? Okay, I think all good, huh? Okay. So just to reiterate my point, there are more than one way to do it, definitely. I only show you one method. Okay? So in case you are curious, for part A, you can also divide by x. Okay? For part B, I don't think there is an alternative lah. So this is probably the most straightforward method I can think of. Okay? Yeah. If you want to divide by x from this step, you can, but why would you want to do that, right? So yeah, just to let you know lah. Okay, let's move on to part C. Okay, for part C, y over 2 equals to x squared over bx plus 3a. Now, this is the bizarre thing about part C. You notice that this is in fraction equal to fraction, right? Never mind. But you see, there are only 2 terms, 1 and 2. So we need to do a bit of manipulation first. But before we do anything, let's observe. Let's take a look at this particular fraction. Do you notice that the denominator has more than 1 term? And this denominator actually got a mix of very, very funny symbols like 3a, bx, these kind of things. So what we can do over here is actually to cross multiply. Okay, because it's fraction equal to fraction, right? And it is an equation, so we can apply cross multiplication. Okay, so when we cross multiply, you get y bracket bx plus 3a equals to 2x squared. Okay, and then you expand bxy plus 3ay equals to 2x squared. Okay, good. Now we have 3 terms. But let's take a look. These 3 terms, okay, which of these can become our variable? Okay, so we can choose this one. Then we need to divide by xy. We can also choose this one, but we divide by y, right? So to me, I will personally prefer to actually divide this one by y, the whole thing by y, right? Because you only need to divide by one variable. So after doing so, in this line, we will divide by y, right? And we will get bx plus 3a equals to 2x squared over y. Okay, are we done yet? No, we are not done, Okay, because why? Again, this is our constant term. But our variable terms are bx and 2x squared over y. Both of these terms, they have a coefficient that is not 1. So we will need to choose one of them to be our leading, to be our big Y, right? And actually, if you notice, this part is conveniently on the right hand side, and we only need to divide by 2, right? Because the coefficient is 2. If we divide by 2, then we get our big Y already. What? Yes. Usually it will have to be 1. Big X don't need. If big X okay, because your M is okay, Y equal to mx plus c, right? Your M is not always 1, right or not? So your M is allowed to be anything. Can? Okay. For me, of course, because it's Y equal to mx plus c, your Y should be a coefficient of 1. Okay, I hope that answers the question. So now we will divide by 2 and we'll get x squared over y equals to b over 2x plus 3 over 2a. Okay, so big Y mx c. And then you notice m is equal to b over 2, c is equal to 3 over 2a. Can? Okay, so far so good. Okay, part D. Do you notice? Okay, y equals to 3a power x, right? Now you see your x in powers, right? So you apply your logarithms. Again, you can choose log, you can choose ln, doesn't matter. Okay, I like to use ln. So ln y equals to ln 3 plus ln ax equals to, now you use the power rule to bring this one down. Okay, ln 3 plus x ln a. Okay, this one should be straightforward lah. Okay, y equals to mx plus c. So quickly identify that your m is ln a and c is ln 3. Okay, this one I think should be straightforward for you guys. Okay, for part E, okay, xy equals to 3abx squared. Now, it starts to be very confusing, right? You see that, oh, so many variables. My main focus over here will be the x squared. Okay, because it's in the power, I want to try to bring this one down first. So let's just apply the power, the logarithms first. Okay, so ln both sides. Okay, we have ln 3ab x squared. Okay, now you notice there are three products, right? Okay, 1, 2, 3. Okay, you can group one of the two together first. Okay, in this case, you can group your 3a together as one big group. Okay, and so you will get ln 3a plus ln b x squared. Now you can bring this down. Okay, it's perfectly okay that you because sometimes you will have ln a b c correct? It's because end of the day you're gonna have ln a plus ln b plus ln c. You can in fact recombine two of them to get you back ln a b, right? It's perfectly okay one. So you can even, okay, let's say I group 3a together. You can apply the logarithms to that one straight away. And so, in your next line, just bring down the power. Okay, ln xy equals to ln 3a plus x squared ln b. So this part will be your y, this part will be your mx, and this part will be your c. Clear? So m will therefore be ln b, and c will be ln 3a. You notice I never split the ln 3a. It is as per what it is. Okay, last but not least, part F is probably the most challenging one. Okay, so you have y squared equals to 1 over x plus a, b minus x squared, right? Now, first thing first, you notice you have this group of terms, right? Okay, it's a very similar situation to part C, right? So you will think of cross multiplication. Now, this is where the important trick comes in. Okay, instead of directly cross multiplying, right? What if I just swap these two terms? Okay, I just do a swap to these two terms. So I will get x plus AB minus x squared equals to 1 over y squared. Okay, so far so good. But then we have another problem. This part, the power, right? Okay, is not convenient to leave it in a power. Okay, because in linear log we don't really this is very unusual, right? Okay, we don't really see this is not practically in the y equal to mx plus c form. Okay, so we have to bring down this power no matter what. But then you notice that if we apply logarithm straight away, let's say we apply straight away, based on this equation, can we bring down the b minus x squared? Okay, for those who remember, if you have ln a plus b, okay, it is not the same as ln a plus ln b. Take note, this is very important. A lot of people make this mistake from experience. So please don't do that. Okay. So instead of directly doing your logarithms, this is what I will do. Okay. I want to isolate this group, this term by itself. So how I can do it is I can bring this x to the other side. Okay. So I can have a power b minus x squared equals to 1 minus 1 over y squared minus x. Now if I apply the logarithm, I can bring down the power. Right? So of course the purpose of me shifting the x is purely to bring down the power. There is no other way. It's not like we are doing any magic trick or because I think it makes sense to bring the x over. There is a reason behind it. And if we don't do it, we cannot bring down the power. That is as simple as it can get. Okay, so nothing too complicated about why we do it. Okay, so in A math, a lot of the steps are logical one. It's not like there is no link. That's why you use this technique. No. In this case, it makes perfect sense to bring the x over. Now, why cannot bring down if there's an x? Okay, so you already see this already, right? What if my x is inside over here? You already know that this is not true, correct? It is only true if I have a product. Then I can put it as ln A plus x ln B. But unfortunately, this is not the same case, right? If this is your x and this is your a b minus x squared, right? You cannot just split them apart and then apply power rule. Cannot. So for convenience, we are just going to bring this a out. So we take out this one, take out this one. You see why we are doing that? This is basically got to do with our logarithm law lah. Okay. Can Okay, now we go back to this. When we apply the logarithm, okay, in the next line, we can actually bring down this term downwards. So b minus x squared ln a equals to ln 1 over y squared minus x. Now, this part, we just need to expand. And when we expand, we get minus x squared ln a plus b ln a equals to ln 1 over y squared minus x. Okay, quickly you'll realize that this part is your c, this part is your big Y, and this part is your mx. Okay? And therefore, you can conclude quickly that this part is your constant for your gradient, and this whole thing is your constant for your y-intercept. Okay? Ln A and C is B ln A. Okay, take note, ln A is a constant, not a variable, because A itself is a constant. So the logarithm of a constant is a constant. Okay, don't mix it up. Okay? Okay, I will give you guys a 5-minute break. Or you want 10 minutes? 5 minutes Okay, we'll come back at 8:20. Okay, 6 minutes Okay, so at this point of time, anybody want to ask me any further questions, please go ahead and ask me. Okay, I'll give you a break first. Because it's a mental load from just now. Yes, can go back. Yes. Okay, you understand why I want to bring the x over, right? And why I cannot bring down if the x is there. Okay. Back to the logarithms law, means I think you forgot that that's what I said a plus something with a power. If you apply the log, you cannot split these two apart. So you might as well split it first before you apply the log. Yeah. Okay, for those who are here, I hope you found my lesson informative lah. Okay. The questions for part one, for question one, I think I chose very specific questions so that it helps you to think a bit further, like what are the techniques that are involved. Okay, can we write B ln A minus? Okay, isn't it the same? You just rearrange only, right? Uh, okay, actually to be clear, you should put it as y equal mx plus c. So I didn't do that lah. Okay, let me do it. Let me do it quickly. Oh my goodness. Yeah, ln A row. This is wrong. Okay, so in a new page, okay, your product rule, right? Ln AB equals to ln A plus ln B. This is not the same as ln A plus B. Hmm. Hmm? Oh, no, because this whole thing is one whole power. Okay, and then you bring down the whole power, ma. This is one whole group, ma. So when you bring down, it will be one whole group also. Then how you split them up is by expansion because this is one term, ln A is one term, this is another term. And you are basically just using your expansion technique. Okay, A bracket B plus C. Okay, this part is your ln A, this part is your B minus X squared. That's it. It's really just expansion. It's different. Okay, we are not applying any logarithm rules here. This is basically just expansion. Okay, don't mix these two up. So how you know when to apply logarithm laws, right? Is when okay, I write this down for you first. Okay, let me write it down for you. Okay, this is ln A B ln A plus. Is it because ln is with an A? Uh, huh? Ln is with an A. Wait, you are talking about this go to this But okay, I think I show you some example will be better So your logarithm rules are generally like that. So basically, if you see over here, right, any operation that involves logarithm rules, right, is all due to the fact that they are all inside the logarithm. Okay, when we had b minus x squared ln a, right? Now, the ln, in order for it to be defined, it must be a ln of something. It cannot be just ln bracket empty. Okay, in this case, because it was already ln a, right, in the first place, that's why it's defined. Okay, and then your b minus x squared, you are applying power rule to bring this down. And then you get this, right? And so this is one whole group. Ln A is the ln of A. This is one package. Okay, and then this is another package, but it's in brackets. Did I answer the question? You let me know if I answer the question. I hope to answer your question. Yes. The reason why I put it behind is because if you put it in front, this is what will happen. there is a difference between these and this. Because the ln is of A, right or not? It's supposed to be only of A. B minus x squared is supposed to be behind because they are not part of the argument of ln A. Okay, when you apply power rule, you always bring it behind. Right? Then you use, if it's behind, like if you basically, okay, I don't know how to make it clear to you. Okay, ln A, if you do it like this, right, it's basically this is one term, this one term. The b minus x squared is not inside the argument of ln. So you can just do it as normal expansion. Whether you put it behind or not, as long as you demarcate this whole thing with a bracket, is clear. We know that it's not part of ln A. It is actually just a product, a normal product. I hope you know what I mean. Okay? Otherwise, are you convinced? What is ln 9A over B anyway? Where got 9? Okay, yeah. I think you get the idea already, right? Basically, when you use power rule, that power does not belong into the inside of the ln. It's supposed to be outside. That's why I always put it behind. To be very clear, I will put a bracket like this. Like this. Okay? Can I move on already? Thanks. I really hope you understand. Okay, so for converting linear form to non-linear equation, this is the reverse, Uno reverse of what we have done. Okay, so this part, I'm going to share with you all a pitfall. A lot of you guys okay, what happened is, this is a plot of 1 over y against x squared. That means to say it's already linearized. Okay, when it's already linearized, right, means any coordinate they tell you, or when they give you information like the coordinate of this line, or whatever, right? This means that the coordinate is representing the linear form, not the raw form. Okay? We will go through this in the examples. I have 2 examples for this. Okay, but to make things simple for you, whenever you are dealing with a linear form, right? That means to say y equal to mx plus c, your job is as follows. Your job is to identify your m and your c. Given your y and your x, your big Y and your big X. Okay, they will tell you what is your big Y and your big X. But it is your job to go and find your M and your C. Now, in linear equations, Sec 1, Sec 2 linear equations, how many points you need in order for you to define a line? You need 2 points, right? Okay, and then, of course, logically speaking, you need 3 points to define a triangle. You need 4 points to define a quadrilateral. You need 5 points to define a pentagon, right? So, to define a line equation, I need to have 2 points. And so, in any linear law equation, when they ask you to convert from linear to non-linear, you always need to try to find 2 coordinates. There are some scenarios whereby you will not have 2 coordinates. Let's take a look. Okay, so first scenario, 2 coordinate, yes, given. The second scenario is if you are given 1 coordinate in the linear form, and you are also given the gradient. Now, if you are given the gradient, right, y equals to mx plus c, okay, your m is already given. If you are given a pair of coordinates, x, y, that means to say, this and this settled. That means you are only left with one thing that you have yet to find, and that is your c. Okay? So if you have yet to find your c, this is what the information is given to you so that you can find your c. Okay? So that's why 1 coordinate and 1 gradient. Now, another scenario is you're given 1 coordinate and 1 axial intercept. So, for example, they tell you the solution to this is 3, or they tell you the y-intercept is 5. Even more clear cut. That means either way, you can make that into a coordinate. So, you have 2 coordinates. Okay. The most difficult example, which people may not get so obviously, right, is this one. 1 coordinate in linear form, and the other one, right, they give you as small x and small y. And then you will need to use that information to find your big X and your big Y. So now you all know what I mean by you all need to find 2 coordinates no matter what. Okay? So that's what I mean. I hope you guys understand. So I will use the examples later on to demonstrate this for you. Okay? Now let's take a look at this example. Consider an equation relating y and x, right? When y over x is plotted against x, a straight line graph is obtained which passes through the points 2, 7 and 4, 11. Now, these 2 points are already in the linear form. Because why? It is already stated very clearly that yx is plotted against x. Remember, it's always y against x. Okay, y against x. If the expansion like that, wait what? Is not okay. Maybe I take this offline with you later. Can? Yeah, you just hold this question to yourself first because I need to move on already. Okay, so sorry about that. Thanks. Okay, so now let's move on. This is the graph. Okay, I have big Y, which is Y over X, and then this is X, right? So in this world, take note, this is in terms of big Y and big X world, not small Y and small X. Okay, in reality, if it's small Y and small X, it will be a curve. Okay, we are not looking at curves here. We are looking at straight lines. Okay, so now we have two coordinates in the linear form. Okay, 2, 7 and 4, 11. Okay, in this case, this is in terms of y over x against x, right? So we just need to find m and we need to find c, straightforward. So for m, okay, you can take coordinate 2 minus coordinate 1 or take coordinate 1 minus coordinate 2. Doesn't matter. As long as it's y2 minus y1, x2 minus x1. As long as this corresponds and this corresponds, no issue. So now let's sub in the values. Okay, 11 minus 7 and 4 minus 2. And that will give me 2. Right? 4 over 2 is 2, right? So that will be our gradient. And notice that it makes sense because this is a positive gradient. And when I plot the points, right, it's actually going up. So this is a way for you to check whether your answer makes sense or not. Okay? If your line graph is going up, you should be expecting a positive gradient. If not, then you should know something is wrong already. Go and check your work. Okay? So now I have my value of m, right? I just need to find my value of c. So in terms of y equals to mx plus c, right? Okay, my m is 2. Okay, now for y and x, we have two coordinates. You just choose one. One is good enough. Okay, so I'm going to choose, in this case, I'm going to choose a more convenient number. The numbers are smaller. So 2 and 7. Okay, let's choose this one. Okay, x equals to 2, y equals to 7. So when you replace y and x into these values, right, you're going to get 7 equals to 2 times 2 equals to c. And therefore, oh my goodness, typo. Okay, and therefore, c is equals to 3. All right. So now you can go back. You already know your c. You already know your m. Okay. Do you know your y and your x? You do. It's given the question. Y over x against x. So you only need to replace all your values as according. So y over x. Give me a while. Y over x equals to 2x plus 3. Okay, so part A done. We have already written the linear form of this equation in terms of m and c. Okay, for part B, make y the subject of the equation from part A. How do I get 3? Okay, I show you again. Okay, so you already know what's your m, right? Okay, you know how you get it, yeah? Okay, so for part B, make y the subject. Okay, simple. Y over x, right? To make y the subject, you just multiply x on both sides. Okay, so y equals to 2x squared plus 3x. Finish. Okay? This question should be simple. Any questions? Don't have? The next one will be difficult. Okay, let's move on. Alright, so this question is modified from one of the papers. Okay, I modified this question and I tested it will work nicely. So let's take a look. Coffee is poured into an empty cup At time t, minutes after the coffee is poured, its temperature exceed room temperature by y degrees Celsius. Now, at this point of time, before we move on, I need you guys to understand how the variables are defined. Okay, because sometimes people don't think very carefully what this actually means. So when I say temperature exceed room temperature by y, right, means I am not looking at the raw value of y. I am looking at the difference between the current value and the room temperature value. That difference is your y. And so the question further tells you that the room temperature is 25 degrees Celsius. Okay? So I think just take note of that. Okay? In case the question sets up a trick inject a trick into this question. So just something for you to think of. Okay? Luckily, this question no trick. It's actually straightforward. Okay, so K and C are constants, right? By plotting Y, ln Y against T. Okay, let's draw out ln Y against T. Ln Y against T. A straight line graph is obtained. It is given that this line passes through 20,88. Okay, 20,88 is somewhere around here. 20,0.88, sorry. Okay, at this point of time, they only give you one coordinate, right? So it should already trigger an alarm. You need to find another pair of coordinate, right? That is given in the next line. It is also given that initially at t equals to 0, the temperature exceeds the room temperature by y equals to 27 degrees. Okay, there we go. This question already tell you very nicely that y is equal to 27, which means it exceeded by 27 degrees. So that means the actual temperature is 52 degrees. You add 27 and 25. So just a food for thought. If the question asks you or they tell you the temperature of the coffee is 52 degrees Celsius, if you use this as your y value, your answer, your whole thing will be wrong. Okay? So that's why I say you need to read the context very carefully. Okay, I repeat. If the question tells you the coffee is a temperature of 52 degrees Celsius, you will need to realize that I am looking, the y, right? The y variable, right, is the amount of temperature that exceeds room temperature. 52 is the current temperature. The room temperature is 25 degrees. And so I am looking for the excess, how much it differs. And the gap is 52 minus 27. Sorry, minus 20. Okay, minus 25 equals to 27. This is in the event the question tells you that the temperature of the cup is 52 degrees and they didn't tell you that it exceeds room temperature. Okay, you just need to take note of the key difference over here. Can? So if t is equal to 0, y is equal to 27. Luckily, not so complicated. Okay, so using this, let's go back to what we are in where we are in right now. We are in the ln y against t world, right? What we have over here is t and y. So cannot. We need to linearize this. And so, in order to go back to our linear world, we are talking about ln y, right? So we need to use the ln of 27, which is ln y is equal to 27 at t is equal to 0. This will form our coordinate. Can? I don't know where is ln 27 to be honest. So you can use let me get a GC here. Okay, ln 27 is 3.29583, so on and so forth. Okay, I will just put it as a list of decimals lah. So you know that roughly, okay, this is higher than 0.88, right? And it should make sense because your temperature is dropping, right? So you expect that your ln y is also dropping, right? Make sense, So your gradient, you expect it to be negative, So this is how you can use context to make sense of your answer. Okay, I hope that you guys actually pick this up. Okay, so now let's look at, we have two coordinates, one over here, and this is 0, 27. Okay, we need to first find the gradient. Okay, and the gradient, right, is simply m equals to ln 27 minus 0.88 over 0 minus 20. Okay, what do we have? Okay, according to my solution, it should be negative 0.12079. Okay? Yes, correct. So that is your gradient. Now, to find your y-intercept, okay, let's go back to our big Y equals to mx plus c. Now, we already know what's our m, right? Now, can we choose a y and a x value that makes sense over here? And right? So, we can choose, okay, if you all are already not very sure, okay, t is your x and this is your y. I hope you all saw this earlier on. I apologize if I didn't clarify this clearly. Okay, so I can choose this coordinate. This is the easiest coordinate to use, right? Because one of them is 0, the other one is ln 27. Nice numbers, right? Okay, so we can use this. Ln 27 is equals to, oh, right, I just realized this is the y-intercept. Don't even need to calculate, right? So convenient. Okay, therefore, going back to our linear form, ln y is equals to negative 0.121 3SF, okay, t plus ln 27. Okay, in this question, I'm not so evil lah. I didn't make y'all convert. I didn't make y'all expect to write ln 27. Okay, so I gave y'all the 3SF value. If y'all realize that lah. So actually this value is 3.30. And so to make y the subject, you just need to remember this basic law. Back to your logarithms, right? You'll realize that e to the ln x is actually equals to x. And ln ex is equal to x. You notice there's this thing in common, right? Okay? Whichever method you use, you're going to get back your x. So I'm going to apply this over here. If I apply the base e onto both, right, I will get y is equal to e power minus 0.121 t plus 3.30. And then it matches your solution. And before we even get the solution, you have realized that, oh, I already have this part in the power, right? So what if I somehow forget how to convert my logarithms into, or rather to bring down the subject, the y subject, right? Then you can just copy down this answer, right? This is a little bit of a trick for you guys if you haven't realized. If you really somehow forget how to convert using your logarithms, right? If you reach this step already, just copy this into here, settle. This is just a tip for you guys lah. But of course, I don't want you guys to just do this blindly also. Okay, so that is the solution. What are we finding after the green line? We are making y the subject law. Because go back to the question. The question is asking you to find y is equals to e power minus 0.12. Basically, they are asking you to make y the subject from the linear form. Okay? So that's the only thing we need to find. Clear? Alright. Anyone got any questions further? Any further questions? Okay, I know I got carried away with this question. But for linear law, a lot of the questions is very straightforward. Okay, it's really just find your linear form and then try to make y your subject. Of course, I set the question, I didn't realize. Or rather, I was excited lah. I forget to go back to the question. Okay, this part, apologies. Right, thanks for pointing out, by the way. So yeah, in this kind of questions, usually it's really just they ask you to find make y the subject, these kind of things. So the steps is standard. You just find your m and your c, these kind of things. Okay. Okay, if not, we'll be moving to the last question. Does anyone need a break? Another 5-minute break. Looks like it's don't need lah. Okay, I mean, last question already. This part is the graph drawing part, and it's quite xiong lah. I think for some of you, I think it will be a bit xiong. Okay, but graph drawing, I think don't need to worry too much. I think the most important thing for graph drawing is to nail down your plotting and everything else. Okay, so actually it's very straightforward. What is the purpose of drawing your graph? Okay, the purpose of drawing your graph for those who take pure, I mean, I don't know about combined science, but for pure physics and pure chem, if you do A levels next time, you might need to linearize your variables, do your experiments, right? Your SPA, right? Your practical, and then you will need to be able to come up with the uh use the linearized form, and then you draw your line equation and all that kind of stuff. Okay, so that is the purpose of linear law, really. It's really more for the sciences, for your experiments and stuff like that. Okay, so you will find that in those kind of examples, a lot of the times, right, you are actually finding you're using your linear form, right, to find your normal values of x and y, and then convert them back into the raw form. Okay, so I don't want to blabber on this too much. Let's do take a look at the examples quickly. Okay, so the approximate mean distance x meters from the center of the sun and the period of orbit t Earth years are recorded in the table. Okay, so you notice the tables are very big, right? Okay, usually when you see the values are very big, very high chance you use logarithm. Apologies, I know that this paper a lot of logarithms but yeah, apologize for that. Not all the time you'll be logarithms, so don't worry too much. Okay, so it is believed that the planets orbiting the sun obeys a law in the form t equals to k x power n, where k and n are constants. Okay, so let's take a look. The most glaring information over here is this form. Okay, your t equals to k x power n. That is the non-linear equation. And usually you should be identifying these kind of things first. Okay. The next thing to know is what are your variables, right? From observation, you can tell that, okay, this is supposed to be what against what, right? So based on context, you need to see what is your independent variable and what is your dependent variable. So based on this equation, you can see that your t is supposed to mimic your y, right? And this is supposed to mimic your mx plus c form. Obviously, it is not lah. Okay, so we need to do a bit of manipulation. And so in part A, express the equation in a form suitable for drawing a straight line graph and draw the graph using appropriate scales for both axes. Okay, so they didn't give you a scale. You need to come up with the scale on your own, right? So first thing first, if t is equal to kx power n, what will you be applying? You will be applying logarithms, right? So, okay, there are a few approaches to this. Again, you can use ln, you can use log. Again, I like to use ln, so let's just stick to that. So ln t equals to ln k plus ln x power n. And so ln k plus n ln x. Okay, so that is your linear form. Okay, so let's clearly identify what our variables and our constants are. Okay, so y is equals to ln t. Okay, and then your x, your big X is your ln x. And the coefficient beside ln x is your gradient, right? So your gradient is your n. And then your y-intercept c is equal to ln k. Just take note. Okay, this is what you'll be using. And so to draw the graph, okay, it will be y against x. And in this case, it will be ln t against ln x. Okay? Now, normally for my students, when it comes to graph drawing, I usually tell them to do a sketch first, a simple sketch. Okay, so let's take a look at this. Before we draw the graph, we need to know what are we using first. Okay, our x and our t, right, are in raw form. We are not looking for that. We are looking to convert them into our log t and log x. So that's what we need to do. Okay, we will need to convert them accordingly first. Okay, so how I'm going to convert? I do have the tables ready. I'm going to write it out actually. Okay, for those interested, you can go and take your calculator, convert all these slowly first. Okay, go ahead. Okay, I'll give you some time to go and do it. Okay, so you'll notice that I will be using three SF values for all of them. Okay. This is just for precision sake. But of course, when you do the actual plot, your values might not be so accurate. So as long as you can get it into the right box, I think it's okay already. Okay. End of the day, about graph drawing, right, is about as precise as possible. It has no way to be perfect one. Okay. So let's take a look at how we can do our scales first. Now, obviously, you will notice that, okay, our ln x, right? Okay, no way it's going to start from zero. It's really too far off already. So we need to figure out the horizontal range and the vertical range, right? So between this and this, what's our range? Okay, the range is about if you take a calculator, 29 minus 21.1 minus 27.4, right? It will be 1.7. Okay, so I need to cater space to draw for around 1.7, that kind of stuff, right? Then for our ln t, I need to cater space to draw between 5.1 and 2.47. Okay, so that's around 2.63. Okay, then what I will do is I will count the number of squares I have on the vertical scale and the horizontal scale. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I got 12 over here, right? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I got 13 squares over here, right? So as long as I can cover at least half of the square, I think half of the grid, I think is good enough already. Okay, so this is ln x, right? And this is ln t, right? For ln x, right, I'm going to try to spread out the 1.7 across the whole thing. So let's see. I got 13 boxes. Um, I can start from here, I suppose. Okay, I think, wow, not very nice. Okay, I think, okay, something like this. Okay, and then from there, I can do, let's see. Okay, y'all know that y'all draw this part over here, right? To indicate that I'm not starting from zero. Okay, this is the origin, right? But obviously, I cannot be doing origin from here, right? So I will then do this all the way. Okay, something like that. I apologize if the line is a bit broken. My pen got some issues. So from here, let's start with 27, maybe over here. Okay, 28, 29, 30, 31. I think this is pretty okay lah. This is good enough. Okay, if not, maybe you can make it a bit wider lah. Okay, 28, 4 squares, right? Then this is 29. I think this is pretty sizable. Can? So how I really determine the spacing is really based on your feel. Okay? You cannot be too precise about everything also. So for your ln t, right? If you start from zero, right, then maybe this is 1, 2, 3, 4, 5. Okay, then you still have a bit of space. I think this is good enough. Okay, so let's take a look. How do we plot 27.4? Now between 27 and 28 is total 20 boxes, right? So 20 boxes means every 2 boxes is 0.1, right? So I need to have 8 boxes, right? 27.4 is somewhere around here. Okay, and where is 2.47? It's near 2.5, right? So it's somewhere around here. Right, can you see? Over here. So when they intersect, right, it will be somewhere around here, right? That will be my first point. And so I will label this as 2.47, 27.4. Sorry, my bad. It's the other way around. Okay, 27.4, 2.47. All right, the next one is 28. 28 is just over here, straightforward. Then 3.38, which is very near to 3.4, right? So 3.4 is 1, 2, 3, 4. Okay, 3.4 is around here. So fourth box from 28 is here. Okay? And that will be my 28.0, 3.38. Okay, the next one, 28.7. Okay, I think a bit difficult to count from 28. I count from 29 backwards, 0.3, right? So I need 6 boxes. Okay, so 29, 6 boxes. 1, 2, 3, 4, 5, 6. I start from here. Okay, that's 29, 28.7. Okay, then I need 4.43, right? 4.43 is around here. No, a bit higher. Here. So somewhere around here. Yeah. Yeah, I will need to check everything to make sure it's correct. This is standard practice. When you all do your plotting, make sure you check properly. So it's okay to take a bit more time to do this. Okay, last but not least, 29.1 here and 5.01, which is just here. Yeah. Okay, can And so now you just need to connect all of them with a straight line. Okay, not so good. Okay, pretty much what I need. No. Okay, yeah, I think that's good enough lah. Okay, so that is the graph. That is how your graph will actually look like. I think it covers at least half. It does cover at least half. Okay, so this is good enough. Okay. So for graph drawing, just be a bit patient. It's fine. You may take a little bit of time, but if you find that, personally for me, if I think you were going to take too much time, maybe do this at the end. Okay, don't spend too much time on doing graph drawing. Not worth it. Okay, you can always come back to this at the end of the paper, left 20 minutes or something to try this out. Okay. Okay, let's try this. Okay, so use your graph to estimate the value of k and n to choose significant figures, but leave your value of k in index notation. Okay, so let's go back to this. Your original equation, right, is t is equals to let's see, ln t is equals to ln k plus n ln x, right? Yes, x-axis is ln x, correct? Okay, so now your job is to go back to your graph and look for your y-intercept and your what do you call that? Your gradient. So from here, you will notice that you can. I mean, for me, I don't normally encourage this, but because the points over here are very how do you say? They are very not very nice, and if a little bit of movement, it will cause a lot of issues, right? So normally, what I will do is I will just take the starting and the last value. Okay. I realized I didn't add the last value in. Let me just do it quickly. Okay. So I'm going to take this value and this value, right? Okay, to form my m. And in this case, my gradient is n, right? So my gradient is really just 5.10 minus 2.47, okay, over 9.1 minus 27.4. Okay, so now if you do your calculation, okay, this is around 1.5470. Okay, 3SF 的话, it will be 1.55. Can? Okay, for your C, good practice is to extend all the way down. Okay, and then from observation, you can tell that maybe this is 1.2, right? It looks like 1.2. Okay, now another way that you can also do this is you can just sub in directly. I think no issues there. So if I were to sub in, right, n is equals to this value, right? And so if I sub in, I got ln t equals to ln k. This is my y-intercept plus n 1.5470 times ln x. I just need to choose a value of x and a value of y. So if you guys have copied down, this is good, but I will try to play back and forth. Can we use calculator and play cheat? What is play cheat? Oh, You mean sub in to calculate? I will strongly advise that how do I put this? Okay, you can use your calculator to go and check if you know what I mean. You can use it to check against your y value and your x value whether it makes your y-intercept and your gradient whether it makes sense. Okay, but this question, the solution, right? They used the actual value, but normal practice for graph drawing, right? They will always get you to extrapolate the points over here. Okay, so in a way, you can use it to check your work first, okay, to make sure that your value is accurate, right? But in this case, right, because for my gradient, right, I use the line, right. When I draw the line, I pass through the first point and the last point, so it makes it valid for me to use those 2 points. You know what I mean? Okay, so that is another tip I can give you. All right. The next thing is ln t equals to ln k plus this value times ln x. So now I just need to choose a pair of ln x and ln t, right? Okay. Let me replace this with another value. Okay, I choose 2.47. Then for ln t, I choose 5.1. Okay, so just do a bit of calculation. Okay, this will give you around 1.278. Okay, if you were to draw this from your diagram, you will realize that, okay, it's around 1.2. Okay, so it does make sense. Okay, now when I sub this back in, okay, I will get ln t equals to 1.28. Okay, I think to clarify about whether you can use calculator and play sheet, let's go back to the question. The question says use your graph. So unfortunately, no. Okay, I just realized this. So when the question says use your graph, you are supposed to strictly use the value from the graph. And as I said, you can use your calculator to verify your answer to make sure that, okay, I think my answer is sound enough, it's logical enough. Okay, but since the question says use the graph, right, you must use your graph values to actually do it. Okay, yeah. So I will take 1.2. 1.2. Wow. Okay, that means to say I worded this question wrongly already. Okay, apologize. I apologize for this. Okay, I should have taken into account that this question used the word use your graph. Okay, so apologize. Okay, but if you use the graph value, it will be 1.2. Okay, but if you use the actual value to sub in, you will get this value. Okay, now to go back to this part, I am going to use the graph value lah. So I will not use this. I will use 1.2. Okay, apologize for that. Okay, so now we have ln t equals to 1.2 plus 1.55 ln x. Okay, yeah, we already answered the question by saying this already. So good enough. Okay, how do you get the 1.5 equation to the 1.278? Oh, yes, I sub in. Okay, and as I said, because the question say use your graph, right? So if you use the graph, right, you're supposed to use the values directly from here. Okay, so that's why I say when you use in the calculator value to sub in, okay, I show you again. Okay, ln t equals to ln k plus n ln x. Okay, my n is 1.5470 based on what I calculated from the graph, right? And then ln x, right, okay, is 27.4. Okay, and then ln t is 2.47. Basically, I plug in from my values previously, right? This is, you are using not the graph, you are using the table of values. That's different. Okay, and then from there, that's how I got my 1.278. So this tells me that my 1.2 is okay. I think somewhat close enough. Okay, but because my pen got some issues, I may not have an accurate drawing. But at least I know it's close to 1.2. Okay, so that's how I got my 1.278. It's used to check my 1.2. Okay? Alright. So before we move on, I will quickly just, what is 1.278? Ln K. Okay, I show you 2.47 is equals to ln K plus n ln X. Wow. Okay, 2.47 equals to ln K plus n ln this value, right? Okay, and then if you rearrange, ln K will be equals to 1.278. So basically, I rearrange. Okay, I hope I answered the question. Sorry, we are overrunning a little bit. Okay, but I also just realized that I haven't made K the subject yet. So yeah, before you move on, you will need to take your base E first. Okay, so do you know how your 1.278 now? Can It's just rearranging Okay, but as I said, this is just used to estimate my my graph drawing over here, which is 1.2. Yeah, you should extend the line Okay, this one my bad because when I prepared this question, I didn't take into consideration all these factors. So basically, I think the most important thing you need to take from this lesson is about how to apply the skills. Okay, I think that's the most important part. As long as you can get the skills right, I think that is the best takeaway you can have already. Okay, so apologies for any blunders that I make in this question. Okay, it's always the graph drawing, a lot of problem one. Okay, so when I use the graph, right, I get ln K is equal to 1.2. Okay, I forgot I need to leave K. Yeah, I need to make K the subject. So from here, I will need to take e power of ln K equals to 1.2. And so I will get K is equal to E 1.2. Okay, can? So that is my K. That is my, and my log, my N is over here. Okay, I put it clearly for you. Okay, I'm going to apologize first if the answer looks a bit funny. Okay. Okay, for part C, using the graph, find the orbital distance of the orbital period of Earth if the distance between Earth and Sun is about this value. Okay, basically, you just need to sub in, you need to know what is this value about. Okay, and this, go back to your table and your variables, right? This is your X. Okay, you are talking about the raw value of X, right? Where did the N come from? Your linear law. Okay, so this is your X, right? And so if you go back to what we have earlier on, is T equals to K X power N, right? Okay, T itself, we are supposed to find the value of T. We know what is K and we know what's N, right? And so uh, K is e to the power of 1.2 and then X power of 1.5470. You notice that I didn't use truncated values. If you're wondering where I get 1.5470 is actually from here. Okay, is this whole thing, bring it to here. Can? And 1.2 comes from here. The e power 1.2 comes from there. Can? So now, if I sub in X is 149.6 times 10 to the power of 9, right? You calculate, you will get the value of T. Okay, sorry for those who need to go off, you go off first. This video will be uploaded, I believe. So no need to worry too much. Okay, but I'm finishing already, so you can stay. Wait ah. Something is wrong here. What happens after the TKX power n? Okay, what happened over here? Huh? Okay, so from part B, right, we got the value of k, right? And then we got the value of n, right? I basically just sub that in. That's all. And then now, right, what the question is given is I have the distance between Earth and the Sun, right? And that is your x. Because your x, right, is defined to be the distance from the center of the Sun, right? Alright? So you sum in your x. The question asks you to find the orbital period. Orbital period is given over here. The period of orbit, t years. So basically, you are just subbing in the value of x to find your value of t. That's all. Can? Okay, why is my answer so weird? What is the number for the power of x? Wait, give me a while. I think there's something wrong over here. Sorry about that. Hmm. How come my answer so weird? Sorry, just give me a while. Okay, I think my answer got some mistake. Okay, I think there's something wrong with my answer. Just let me check first. Okay, those who need to go off, I think you go off first. I will upload. This will be uploaded. Okay, not to worry. Hmm? How come so weird? Hmm? Okay. Okay, this is correct. One T. Okay. Okay, guys. I think I know what's the issue already. Just let me do a quick check. Okay. X, non-X, 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 non-X. Okay, this is very weird. Oh, okay, guys. I know what's the issue already. Okay, this one is my bad. Okay, when you go back to the graph, right, you will realize that. Okay, sorry, this one let me explain clearly again. I didn't take into account, right, that this part of the graph is truncated. Okay, I'm going to point you guys back that this part of the graph is truncated. Okay, so because it's truncated, the y-intercept over here cannot be deduced from the graph. Okay, I'm very sorry about that. This part I really never noticed. Okay, and to be very honest, if I were to do this in an exam, I will blunder. Okay, so I will be very transparent and let you guys know that this part, okay, is a mistake. So whenever you use a truncated value like this, right, you cannot just read off from the graph. So then you have no choice. Okay, I say no choice, but to calculate directly. Okay, so for those who are still here, thank you for staying with me. I really appreciate it. Okay, so I will show you guys how to find the value of ln k. Okay, and to answer your question, sorry, I think I miscalculated this whole thing. So let me show you how to calculate again. Can? Now, you have the value of n, right? Okay, so you have ln t is equals to ln k plus n ln x. Okay, so you already know your value of ln of your k, right? You just need to find values of ln x and your value of ln t, and then you are supposed to find ln k. So I just plug any value I want for my ln x and my ln t, right? Ln x I can plug in, let's say 27.4. Then ln t I can plug in 2.47. Okay. Okay, if I do 2.47 minus 1.5470 times 27.4. Okay, you will get 39.9178. Okay, this person over here, I hope you know how I got it. Can? So this is your long K. So my apologies, it's not 1.278. Okay, it's a calculation error. Okay, now I have long K is equals to long k is equal to negative 39.9178, right? I will need to find the value of k, which means I need to raise to the power of, I need to raise base e, right, to the power of long k, right? Then k is equals to e power minus 39.9. Obviously, I cannot leave this, I cannot really go and evaluate this line, it's too large already. So I will just leave it like that, E3SF. Can? Okay, so now for part E, going back to what we have, t is equals to k x power n. Okay, your k is e power 39.9. Your x, okay, is power 1.5470. Okay, and this is your t. Now, x, right, was already, I already told you, right, is 149.6 times 10 to the power 9, right? If you raise it to the power of 1.5470, okay, and then you just need to evaluate this whole thing. Okay, so once you evaluate, right, okay, this will give you around 0.9104. The nearest integer is 1. So you see, the orbit of Earth around the sun is 1, right? It makes a lot of sense. Because 365 Earth years, one Earth year is 365 days, which is exactly one orbit. So you know your answer makes sense. Okay? Really apologies for the mistakes for the part B, because this one I really never noticed. Okay, I planned everything else, but this was the question that I had difficulties planning. So my bad. Okay, part D. A scientist proposed that the average distance from Mars from the sun is blah 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 with the orbital period being 1.88. Now, this is your x, this is your t. Plot this point on the graph, hence explain this if this proposal is possible. So you just need to find ln x, ln t, right? Okay, ln 1.88 is 0.6312 and ln x, right, is, wow, this value very big. Okay, times 10 power 10. Okay, 23.921. So on the graph, okay, 23.921. Okay, 23 is not inside. GG. Again, I never take this into consideration. Okay, but this part, let me modify the question on the spot. Okay, if you can't plot this point on the graph, right? Okay, again, my bad. I can twist this question and ask you. You don't have to plot. You just straight away find whether it's reasonable or not. So how do you check if it's reasonable? It's as follows. Okay, go back to your equation. T equals to e power 39.9 x power 1.5470. You know what is your x, right? Okay, your x is 2.4 times 10 to the power of 10. Okay, you sub in, you evaluate this whole thing, you find the value of t. Okay, let's try. So if we sub in, okay, 2.45 times 10 to the power of 10, power 1.5470. Okay, this answer turns out to be 0.0554. Okay, is this close to 1.88 or not? Certainly not. And so you know your answer is wrong, right? So you know this value and this value okay, is very far apart. And that's how you know that this proposal is not reasonable. Okay? So question 4, wow, question 4 was a headache. Didn't expect it to be like that. So, okay, any questions for question 4? What is the number 0.5? Okay, 0.554. Let me write down again. 0.554. 0.0554. Can? Okay, if no, then I think what about part C? Part C is 1. What number?
The 14 thing.
You type out can or not?
Or like the X value.
Sorry, I cannot hear you very clearly. You want to type out instead? Part C, the number, right? X value. Yes. You sub in, no? Now, your 1.96 times 10 to the power 9, no? Is this one? Bring over here. Is that what you're asking? Can Okay, good. So if no questions, right? By the way, just now you asked me a question earlier on, right? We want to clarify this. Okay, the rest, right? Thank you so much for joining the class. Okay, I really apologize for question 4. That one is not intentional. Okay, it was lack of a foresight that had some issues, lah. Okay, for those who, I mean, it's already done. Okay, so thank you so much for coming. I hope that you find the lesson fruitful. Okay, thank you. Yes, last page. You need me to explain something, or you just need to copy down stuff? You need me to explain anything again or not? You don't understand part B, huh? Okay. So for part B, right? Ah, okay. Okay, so for part B, give me a while. Okay, part B, right? Basically, you have your linearized equation, right, over here, right? Okay, your job is to find the unknowns. Ln k, you're supposed to find k and n, right? Correct. And then over here you have a table of values for ln x and ln t, right? Correct. So your job is really to just find the value of n and to find the value of ln k. But n, right, is your gradient. Correct. Your n is your gradient, right? So when you go back to this graph over here, you just need to find the gradient, which you can take from this point and you can take from this point. Okay, you just need to take the gradient over here, and then this gradient, right, will be your n.
Yeah, I
That's
don't understand the ln case part.
you don't understand the long part, huh?
The like the
Long k is it? You're asking about long k,
like why you need to add e?
Why you need to add the e? Okay, because the question asks you to find integral of k.
Also ln e equals to 1. Then
Okay, ln e to power ln something it will end up become the x. Also, ln e x is also equal to x, right? So I'm using these properties, right, to bring down the k. That's what I'm doing. You understand? And this is actually similar to what we did just now. I show you this question. This one. Can you see that I put the base e so that I can bring down the y or not? That's exactly what I was doing. This is one of your logarithms property. Can? Okay. Then for your part C, right? You are given this value, right? And this is the distance between Earth and Sun, correct? What variable is that? Okay. If you go back to this question, right, that is the distance from the center of the Sun, right, to Earth. And so this is your x, correct? This is your x, right? And then, right, from your part B, right, you have your k, you have your n, right? You also have the original equation, which is this one. So from here, right, you have your k, you have your n, and you also have your x, right? What are you supposed to find? You are supposed to find the nearest integer in Earth years. And that is your t long. If you go back to the question, right, that is the period of orbit t years. Can? And therefore, you realize that I sub in k, I sub in n, and I sub in x direct. And that's how I got 0.9104. Okay, you also notice that I didn't need to convert into ln x, right? And that's because I'm using the original equation. Why can I do that? Because from part B, I already know the answer of k. I also already know the answer for n. And that's why I sub in to get my k, to get my t. And that is the solution to the question. Can? Does that answer the question? Okay, part D. Okay, part D is similar, except they tell you this is x and this is t, right? You can do the same thing. You sub in your x, and then you get your t. Now, as I mentioned, right, it is my lack of foresight that okay, this value, right, is not inside. It's not actually something I can plot inside the graph. The coordinate is too far off already, so I cannot plot this on the graph. That's why I just tell you to just sub it in directly. Okay, so what you should be doing, right, is you just take in your x value, right? You sub it in, you get this is your value of your t. And this should be the value that corresponds to your total orbital period. However, the question gives you 1.88, right? Correct or not? If they give you 1.88 and you calculate out using your 2.45 times 10 to the power of 10, right? That means to say these two values are very far apart. So it doesn't make sense anymore. Correct or not? So if this actual calculation and what was proposed, right, which is 1.88, right, if they are far apart, that means when you draw the line, this coordinate will be somewhere around here. It's very far away from the line. And so it is not a reasonable proposal. Can? So when the question asks you to plot, if you are able to plot based on the range they give you, right, then you should be able to plot and you should be able to deduce that, oh, it's very far away from the line. That was the original intention of the question. But in this case, you cannot plot lah, because based on my skill, cannot plot one. So what I do is I sub in the value of x to find my value of t. But it turns out that my value of t is very far apart. That's why the answer don't make sense. Okay? Okay, you are talking about this, right? Okay, basically, when you have ln of something to the power of b minus x squared, right? You are applying power rule to bring this down, right? And the power rule is just ln a n. You bring down the n times ln a. Take note, it is not the same as ln a n. Okay, the n is outside the ln. It is not supposed to be the bracket. Oh, part B for the last answer. Oh, sorry, my bad. Okay, part B, which part are you still not sure?
Like, why you need to take E?
Sorry?
Why you need to like put the E there?
You mean why I need to take the value? Okay, originally what do I have? From this equation, I got ln k is equals to, ln k is equals to what? Ln k is equals to negative 29.9178, right? What am I supposed to find? I'm supposed to find k being the subject, right? Correct or not? So in order for me to make this a subject, is basically, okay, one way I like to see is I can see this as log base E. And if you remember your log, your change of base, right, is actually this power to this equals to k. But another approach I like to use is instead of remembering this, I just remember, okay, if e to the power of ln function, right, then it will just give me the function back. So I'm basically applying this law. This is a more convenient law for me. I like to use this law because this is the natural behavior of e and ln and the logarithm. Right? They are in fact, if you draw the graph, e to the power of x is like that, right? Ln n is like that, right? Okay, you get it, okay, good. Can any more questions? Wow. For linearizing, how do we know to stop linearizing and determine? Yes, must make the y coefficient of 1. But as I said, your y doesn't always necessarily need to be purely y. It can be a mix of everything. Can? Okay, you all continue to ask. Let me pack up my stuff first.
Wait, so for question 3 is the same.
Say again?
For question 3, the ln E is the same thing.
For question 3, the ln is the same. Yes. You're talking about question 3, the last part, right? Same.
Yeah, so y equals e to the power of minus 0.121 t plus 3.30.
All right. Yes. You're using your change of base law over there. Okay?
Wait, then the equation before that is ln y equals e to the power of minus 0.12.
Yes. Correct. Correct. That's why I apply the E law. Can? I hope I answered your question. Because, okay, original is ln y equal to minus 1, minus 0.0, minus 0.121 t plus 3.30, right?
Yeah.
So I apply the E law to both sides law. Or you can just convert it, you can just use your change of base law. Whichever works for you. Okay?
Wait, so the original equation is without the e?
Don't have lah. I introduce it
Oh.
So I think for you, you forgot about a lot of your logarithm rules already lah. I will say best to go and revise on it. From the questions you asked me, I think you forgot quite a lot of your logarithm rules. So your exponents and your logarithm. So best to go and revise. Okay? Because
Okay,
initial law, you
then
don't use it a lot. Sorry?
for the long question I asked you just now, the b minus x squared ln a, that one.
B minus x squared. No, sorry. B minus x squared ln B.
Ln a.
Wait. Last question, right?
No, the question one.
Oh, question one. Okay. You mean the power B minus x squared, is it?
Yeah.
Why?
Uh, is it cause like the ln rule is ln a minus ln b, but then this one is bracket b minus x squared,
Yeah, correct.
so you can't apply the rule.
Okay. You see, you are asking about the power rule, how I bring down, right?
No,
Okay, then. Yeah.
like I
About?
think the bracket b minus x squared ln
Ah,
a.
ah.
Like I was wondering why can't you just like why you can just expand it?
Isn't that what I did? I expanded,
Like why you can expand?
Okay. Because ln A is one term by itself, right? Then your B minus x squared is like A minus B. It's like a term minus a term, right? So in this case, it is just a normal expansion. You're not applying logarithm rules over here.
Oh, okay.
Can
But
So
if inside the bracket there's ln, then you have to apply.
if inside the bracket got a lot. Okay, my answer to this question is it won't be so complicated. But if it really happens, your ln A if it is inside the bracket, right, and it's not related to the outside ln A, right, you are again doing a normal expansion. Okay? So you get what I mean?
Okay, repeat.
Uh give me a while. You're asking if got the ln N inside a bracket, right?
Yeah.
Okay. Let's say ln A power ln B, for example. Can, right? I
Yeah.
bring it down, it becomes ln B times ln A. This ln B and ln A are not related. Does that answer your question? So if I include another x squared over here, then I will have equal to, by a power rule, ln B minus x squared. And when I expand, it will just be ln B bracket ln A minus x squared ln A. Okay? The ln B and the ln A are still not related to each other. That's why I put bracket for both of them. They do not have any further interaction with each other. Can?
So is this usually tested?
Sorry?
Is this usually tested?
No lah, very rare lah. But you need to know that, okay, if you want to bring this up into ln A power ln B, you can still do it. By power rule, it still makes sense. But otherwise, there is no further interaction within these two. Basically, ln B times ln A is not the same as ln B ln AB lah. It's not the same. That's all. You only remember the power rule, right? It's just A times B. You split it up into ln A plus ln B. Obviously, these two are not the same.
Okay.
Yeah?
Yeah.
Okay. No more questions already?
Can you send the answer?
It will be uploaded. The video will be uploaded.
Wait, where?
YouTube.
Oh, okay.
Yeah.
So you all will send the link.
Say again.
Will the admin send the link?
The link. What link?
The YouTube link.
It's under the Overmark website. YouTube. If they will upload, then you will find out from there.
Okay.
Okay. If not, I will find a way to upload all this lah. I see what I can do. Okay.
Okay.
Thank you.
Thank
Any further
you.
questions?
No.
All right. Thank you so much. Okay. See you
Thank
guys.
you.
Bye bye.